Experiment 6 is about conductance of solutions. Okay? The main objectives or the objectives of experiment 6 are the following: to measure and compare the conductance of weak and strong electrolytes, to study the effect of concentration of the conductance for weak and strong electrolytes, and to test the additivity rule of conductance. In experiment 6, you are introduced to this concept of electrolytes. Now, this is not new to you because we have discussed about electrolytes in chapter 4. So, electrolytes are aqueous samples of compounds that conduct electricity. So, you can classify electrolytes as either strong or weak electrolytes depending on how their conductance of electricity is. Okay, usually the strong electrolytes are the salts and the strong acids and strong bases, while weak electrolytes are weak acids and weak bases. So for compounds that doesn't conduct electricity, we call them non-electrolytes. Now, so we're talking about conducting electricity. So this has something to do with conductivity. So conductivity is the degree to which specified materials conduct electricity. Usually, it is calculated as the ratio of the current density in the material to the electric field that causes the flow of current. Now, if we're going to base it on Ohm's law, we could say conductivity is the reciprocal of resistivity. Now, ionic compounds, when they dissolve in water, they form charged ions which are capable of transporting an electric current. Now, the conductance of these solutions is high and dependent on the nature and the concentration of the ions. So usually when we're talking about isomolar solutions, these are solutions that have the same molarity. Now, we don't expect the ionic compounds in the form of salts to have the same conductivity even though they are isomolar solutions. Okay, so they do not have the same conductance because of the different charges of the ions and their different mobilities in solution. And in fact, we could say that we cannot say conductivity is dependent on concentration, because you have to take into consideration the mobility of the charges of the ions that dissolve in the solution. Now, for fairly dilute solutions, the additivity rule is applied. So, additivity rule, this is the conductance of a mixture of solution is equals to the sum of the conductances of the individual solutions. Okay? So for this rule to apply, the number of moles of each ion in the separate solutions and in the mixture should be equal, and the components of the mixture should not react with one another. And you're going to see it in this experiment. Okay? How additivity rule is applied. So technically, what you're going to do here is just to prefer solution and measure their conductivity. So in the Lager probe, you're going to attach the conductivity probe to the interface, the Vernier interface. And in the first part of the experiment, you're going to record the conductance of different types of ionic compounds. Okay, I think it's something to do with the charge that it has there. So you're going to fill the beaker with distilled water, and then you record the conductance. So you do it every time you use a new ionic compound. So once you record the conductance, you're going to add 1 drop of 0.1 molar NaOH, and then you record the conductance, and then you're going to add another drop, then record. Okay, you continue doing this until you get a total of 8 drops. So each drop that you put there, you're going to record the conductance. And then you're going to repeat this time using 0.1 molar of calcium nitrate. So distilled water first, conductance, 1 drop of calcium nitrate, and then conductance, and then until you get 8 drops. And then you do it again, this time using aluminum chloride. Now this is not included in the manual, but I want you to see what's the difference if you use different charges of ions. And you're going to plot all these three sets of data in one graph and include in your lab report. For the second part of the experiment, so this is where you're going to prepare different solutions. So you prepare 50 ml of 0.01 molar HCl and 50 ml of 0.005 molar of HCl. And then you're going to prepare other solutions, 50 ml that has a concentration of 0.05, sodium chloride, sodium nitrate, ammonia, and acetic acid. So in each of these solution, you're going to record their conductance. And then you're going to prepare 50 ml of each of the following solution having a concentration of 0.01 molar of NaCl, NaNO3, NH3, and acetic acid. And then what you're going to do to the solution, you're going to mix them. So you're going to get 25 ml and 0.01 molar concentration and mix the following. So HCl, you mix it with sodium nitrate. HCl, you mix it with NaCl. And ammonia, you mix it with acetic acid. And what you're going to do, you're going to record the conductance of the resulting mixture. Now, for your lab report, aside providing you the conductance of those 8 drops of ionic compounds, you will also be provided with this set of data. But the one that will be given to you is the experimental data. Okay? So everything here will be provided. But here, what you're going to do is you're going to apply the additivity rule. So you're going to do some calculations wherein, based on the experimental conductance that you get here, so when you mix them, what would be the calculated conductance, and compare it with the given experimental conductance. Okay? So you're going to submit this, and then the graph for the 3 plots, and then the answers to question. Now the answers to questions mostly is just C1B1 equals to C2B2 problem that we have discussed during chapter 4.